back again to the lecture number 25. And in this lecture, we will solve 3 questions from exercise 8.1, that is question number 4, 5 and 6. Okay, so without wasting much time, let's start with the question number 4. This is question number 4. In this question it is given so that, it means you have to prove that the diagonals of a square are equal and bisect each other at right angle. Okay, so we have to prove in case of a square. Let's draw a square first. Let's draw a square first. Right, suppose this is a square A, B, C and D. So in this square, we know it has 2 diagonals, AC and BD, right? And you have to prove that these 2 diagonals are equal. That means AC is equal to BD. So we have to prove, what we have to prove? We have to prove that the 2 diagonals are equal. AC is equal to BD. Understood? And bisect each other. Bisect each other means at the point of intersection, this diagonal is divided into 2 halves. Okay. Similarly, this diagonal is divided into 2 equal halves. So we have to prove that this half is equal to this half and this half is equal to this half. Okay. Since we know, or since we have to prove in the statement 1 that this is equal to this, it means all the 4 halves must be equal. That we need to prove. So we have to prove BO is equal to DO and AO is equal to CO. Okay. Next, what we will prove? We will prove both the diagonal bisect each other as well as at right angle. It means the angle between them, the angle between these 2 diagonals is 90 degree. Okay. So we have to prove AOB is equal to BOC is equal to COD is equal to DOA is equal to 90 degree. Okay. Is equal to COD is equal to DOA is equal to 90 degree. We have to prove all these 3 statements. Okay. So let us prove. Since it is already given, ABCD is a square. So since ABCD is a square, it means all the 4 sides are of equal length. Yes, and each angle is 90 degree. We know it since it is a square. So in the given statement you can write that AB is equal to BC is equal to CD is equal to DA. All the 4 sides are of equal length and all the angles are of equal measure. So angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. So we know it. From this given statement we have to prove these 3 statements. So let us prove the first statement that the 2 diagonal AC and BD are equal. Okay. So for this we have to take, or we have to compare 2 triangles. Triangle ABC, this triangle, and triangle BCD. Okay. Which triangle? This triangle and BCD triangle. These 2 triangles. Okay. So between triangle ABC and triangle BCD, okay. So what are the possible conditions here? Here, as you can see, for the triangle ABC, AB side is equal to DC side of the triangle BCD. So you can write AB is equal to DC. Why? Because it is already given that it is a square, so its pair of opposite sides or as well as all the 4 sides are equal. So it is given. Second condition is for the triangle ABC, this angle is 90 degree, and for the triangle BCD, this angle is also 90 degree. So angle B is equal to angle C is equal to 90 degree. It is also given. Now, third condition is for triangle ABC, BC is a side, and for the triangle BCD, BC is also another side. So BC side is common side to both the triangle. Common side. So by side angle side congruency, so by side angle side congruency, we can write these two triangles ABC and BCD are congruent. So by SAS congruency, triangle ABC is congruent to which triangle? Triangle BCD. Okay. Next, we have proved that both the triangles are now become congruent. Now, let's consider their corresponding parts. See, for the triangle ABC, AC is a side. Yes. For the triangle BCD, BD is a side. Yes. But we know what? That this triangle ABC is congruent to the triangle BCD, and these two are their corresponding parts. We know if any two triangles are congruent, then their corresponding parts, that means their corresponding sides as well as their corresponding angle must be equal due to axiom number 7.2. Hence we have proved that AC is equal to BD, and this AC and BD are the two diagonals of this square. Now we have to prove this, that AC is equal to BD, and here we have proved the first step. Okay, so next move to the proof of the second statement. So now let us come to proving the second statement, that the two diagonals are bisecting each other. That means BO is equal to DO and AO is equal to CO. We have to prove it. So in order to prove it, we have to take any two triangles. Okay, out of the four triangles, we have to compare any two triangles. Let's say we are considering this triangle BOC and this triangle AOD. Okay, so between triangle, this is the proof of second statement. So between the triangle BOC and triangle AOD, okay, between these two triangles we have to write. So here the first statement is for the triangle BOC and for the triangle AOD. Okay, see, already we know AD and BC are two parallel lines. Why? Because it is a square. A square is also a parallelogram. Yes or no? Yes. So we can say that the pair of opposite sides are parallels. Done. So if AD and BC are two parallel lines, right, and this is the transversal line, then can we say these two angles are equal? AD, okay, and this is BC, and AC is the transversal line. Then can we say this angle is equal to this angle? Yes, we can say, because they are alternate interior angles. And we know if there are two parallel lines and a transversal line, then the alternate interior angles are equal. So we can write that this angle is equal to this angle. Okay, because they are alternate interior angles. So DAO, angle DAO is equal to this angle BCO. Why? Because they are alternate interior. Right. Next, for the triangle BOC, BC is a side. Okay. For the triangle AOD, AD is a side, and we know BC is equal to AD. Why? See, BC is equal to AD because it is a square. So pair of opposite sides are also equal. So BC is equal to AD. It is given. Third statement or third condition is, if we consider AD and BC be two parallel lines and DB is a transversal line, okay, then DB is a transversal line, then this angle is equal to this angle. Means this angle is equal to this angle. Why? Because here also these two angles are pair of alternate interior angles, and the pair of alternate interior angles are equal. So we can write ADO angle is equal to which angle? CBO angle. This angle is equal to this angle. CBO angle. This angle is equal to this angle. Okay. So CBO angle. Why? Because they are alternate interior, because they are alternate interior. Okay, so by angle, this is side and angle. So by angle, side, angle, we can say that this triangle BOC is congruent to the triangle AOT. Okay, so by ASA congruency, we can say triangle BOC is congruent to the triangle AOT. Understood? Now this two small triangle will become congruent. If any two triangles are congruent, then we know that corresponding parts must be equal. So let's talk about that corresponding parts. OB is a part of which triangle? BOC, right? And OD is a part of which triangle? AOD. But we know this BOC triangle is congruent to this triangle AOD. So we can write their corresponding side must be equal. Okay. Similarly, if we consider OC as a part of BOC triangle and AO is a part of AOD triangle, okay, AOD triangle, OA is a part of AOD triangle, then these two triangles are become congruent. Since they are congruent, that means their corresponding parts must be equal. Okay, so these are due to cyclicity after axiom 7. Okay, so here what we have found? Here we have found that first thing, OB is equal to OD. It means BD diagonal is bisected into two equal halves. See, OB is equal to OD means what? BD diagonal is bisected. Okay, so we can write, so BD diagonal is bisected, and second thing is OC is equal to OA. OC is equal to OA. It means what? It means the total diagonal AC is divided into two equal halves, OA and OC. It means this AC is also bisected, okay, at the point of intersection. And AC diagonal are bisected. Both are bisected. Yes or no? Yes. By each other. See, we have to prove this. BO is equal to DO. We have proved. AO is equal to CO. Here we have proved. It means the two diagonals of a square are bisecting each other. Okay. And finally, we will move to the third statement to prove, that is, the angle between the two diagonals is 90 degree. Right? We will prove angle AOB, angle BOC, angle COD, or angle DOA is equal to 90 degree. It means this diagonal is perpendicular to this diagonal. Okay, so how we can prove it? In order to prove it, we have to another take two triangles, that is triangle BOC and COD. Right, so let us compare them. So between triangle BOC and triangle COD, okay, so what are the possible conditions that are resulting here? As you can see, from the second statement, we have proved that BO is equal to DO. BO is equal to DO. And AO is equal to CO. AO is equal to CO. We have proved it already, right? Now, here, for the triangle BOC, this OB is equal to, for the triangle COD, this OD. Why? Because we have proved it. BO is equal to DO, okay, and this is bisector, or this is bisecting, so OB is equal to OD. We can write it, OB is equal to OD, okay. Why? Because it is proved by proved. Second condition, for the triangle OBC, BC is a side, for the triangle OCD, CD is a side, okay, but both the sides are equal. Why? Because it is a square, and here all the four sides are of equal length, so you can write this is equal to CD. It is given, right? Third condition is, for the triangle OBC, OC is a side, and for the triangle OCD, OC is also a side. So OC is common side to both the triangle, common side. So by SSS congruency, by SSS congruency, we can write that a triangle BOC is congruent to the triangle COD. Okay. Now these two triangles are now congruent. Now, if any two triangles are congruent, we know their corresponding parts must be equal, right? So this angle is a part of which triangle? OBC. Which angle? BOC angle. So BOC angle is a part of triangle OBC. Similarly, this angle COD is a part of which triangle? COD triangle. But initially we know that triangle BOC and triangle COD are congruent. It means their corresponding angle must be equal. It is due to axiom 7.2. Okay, this is now clear. Next thing, see, BD is a line, yes, and OC stands on it, yes. So BD is a line and OC stands on it. It means they are formed two angles. BD is a line, OC stands on it. They are formed two angles, and these two angles are known as linear pair angles, and the sum of two linear pair angles is equal to 180 degree. So we can write implies BOC plus COD is equal to 180 degree because they are linear pair. Is it clear? So now already we have proved that BOC is equal to COD, right? So in the place of BOD we can substitute COD plus again another COD is equal to 180 degree. So COD plus COD is 2 COD is equal to 180 degree, implies COD is equal to 180 degree by 2. Is it clear? Is equal to how much? 90 degree. So what we have found? We have found the value of the angle COD is equal to 90 degree. This is 90 degree. Okay, and COD is equal to BOC. So we can write BOC is also 90. So this is also 90. It means what? It means BD diagonal is perpendicular to this diagonal. Yes or no? Because angle between them is 90 degree. So BD diagonal is perpendicular to this diagonal. Implies we can write BD diagonal is perpendicular to AC. Or you can write this angle is 90 degree, this angle is 90 degree, this angle is 90 degree, this angle is 90 degree. Okay, why? Because if it is 90, then its vertical opposite angle also 90. If it is 90, its vertical angle opposite also 90. Hence we have found that both the diagonals are bisecting each other, they are equal, as well as they are bisecting at a right angle. BD perpendicular to AC. Okay, hence it is proved. Understood? So let us solve the question number 5. Here we have to show that if the diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. If you analyze, then you can see this question is just opposite of question number 4. In question number 4 we have that it is a square, then we have to prove that their diagonals are equal and they bisect each other at right angle. But here it is given there is a only quadrilateral. Simply there is a quadrilateral, right? Simply there is a quadrilateral like this. Let's say this is a quadrilateral. Okay, A, B, C, D. And in this quadrilateral it is given the diagonals AC and BD are equal. Okay, so here the diagonal AC and BD are equal and bisect each other. It means this is the point of intersection. So they bisect each other means this is equal to this half is equal to this half. So OB is equal to OD and this half OA is equal to OC. OA is equal to OC. And they bisect each other at right angle. It means the angle between the two diagonals is 90 degree. So each angle is 90 degree. This is 90 degree, 90 degree and 90 degree. So simply we can write that the diagonal AC is perpendicular to the diagonal BD. That means the angle between them is 90 degree. So if it happens, then we have to prove that this simple quadrilateral is a square. We have to prove. What we have to prove? It is a square. So to prove ABCD is a square. Okay. So ABCD is a square. It means what? It means we have to show that each side are equal. Okay. It means we have to show AB is equal to BC is equal to CD is equal to DA. Not only this property, but also we have proved that each angle is also equal to 90 degree. Right? So we have to prove angle A, angle B, angle C and angle D is equal to 90 degree. Okay? So let us prove. So let us prove the statement number 1. Okay. In order to prove it, we have to consider first this triangle with this triangle, AOB and COD. Okay. So between triangle AOB and triangle COD, the three possible conditions are this side of triangle AOB is equal to this side of the triangle COD. Okay. So OA is equal to OC. Second, this angle is 90 degree for the triangle AOB and this angle is 90 degree for the triangle COD. So for triangle AOB, the angle AOB and angle COD are equal. They are 90 degree. Third condition, here OB for the triangle AOB is equal to OD for the triangle COD. Yes, OB is equal to OD. All these three conditions are given here. All these three conditions are given here. So by side, angle, side, these two triangles are now become congruent. So we can write triangle AOB is congruent to the triangle COD. Do you understand this? So these two triangles are congruent. If any two triangles are congruent, then their corresponding parts must be equal. Okay, if we consider AOB triangle, then AB is a part. And if we consider COD triangle, then CD is a part. Since these two triangles are congruent, that means their corresponding sides must be equal due to simplicity or axiom 7.2. So we have proved AB is equal to CD. This is, let's say, equation number. Okay, we have proved it by taking or by considering these two triangles. These two triangles are congruent. That means this side AB is equal to this side C. Now similarly, if we consider this triangle with this triangle and we have to prove that these two triangles are congruent, then we can say their corresponding parts must be equal. Okay, we will find the same result. Like this, we have to follow the procedure and we have to prove that the triangle AOD is congruent to the triangle BOC, following the same procedure. So simply I am writing similarly we can prove AOD triangle AOD is congruent to the triangle BOC. Are you getting my point? If two triangles are congruent, then the corresponding parts must be equal. AD is a part of AOD triangle. AD is a part of AOD triangle. BC is a part of BOC triangle. So these two triangles are congruent. It means their corresponding parts, corresponding sides must be equal. Okay. So this is equation number 2. Now what will we do next? Now we have to again compare this triangle BOC with DOC. BOC with DOC. So let us compare it. Let us compare here. Right. So between triangle BOC and triangle DOC. Okay. BOC and DOC. these two triangles. See, BO of the triangle BOC is equal to DO of the triangle DOC. BO is equal to DO. Why? Because it is given. Second, this angle is 90 degree. That means angle BOC is 90. And this angle is also 90 degree. That means angle COD is 90. So angle BOC and angle COD is 90 degree. It is already given. The angle between them is perpendicular or 90 degree. Third condition. OC is the side of the triangle BOC and OC is the same side for the triangle COD. So OC is the common side to both the triangles. So OC is equal to OC. They are common side. Right? So by side, angle, side, we can write this triangle is congruent to this triangle. So simply I can write triangle BOC is congruent to the triangle DOC. Is it clear? Now let us move or let us consider their corresponding parts. If we consider BOC triangle, then BC is a side. Done. So I can write implies. So BC is a side. Similarly, if I consider COD triangle, then CD is also a side. Okay. So CD is also a side. But we have proved now that this triangle is congruent to this triangle. It means that corresponding parts must be equal. So BC is equal to CD. We can write it. Understood? So we can write BC is equal to CD. Let's say this is our equation number 3. Equation number 3. Okay. So from equation 1 we have found AB is equal to CD. This side is equal to this side. In equation 2 we have found AD is equal to BC. This side is equal to this side. In equation 3 we have found BC is equal to CD. Right. So let us analyze all the 3 equations. So from equation 1, 2 and 3 we have found first AB is equal to CD, right? And see, in equation 3 we have found CD is equal to BC. CD is equal to BC. So CD is equal to BC. And from equation 2 we have found BC is equal to AD, right? So BC is equal to AD. So what you have seen here, you have seen that all the 4 sides of this quadrilateral are equal. This is equal to this. CD is equal to BC. So CD is equal to BC. And BC is equal to AD. So all the 4 sides are equal now. All the 4 sides are equal. So now we have proved the first statement that all the sides of a quadrilateral are equal. But till now we have not proved that it is a square. No. We have to prove another statement also, that each angle is 90 degree. Okay. So this is the proof for the first statement. Proved. Let us prove the second statement, that each angle is 90 degree. So in the first statement we have proved that in this quadrilateral ABCD all the 4 sides are equal. It means AB is equal to BC is equal to CD is equal to DA. Right. So we need to prove another statement. Okay, that each angle of this quadrilateral is 90 degrees, so that this quadrilateral now becomes a square. Okay. So let us prove the second statement, that each angle is 90 degrees. In order to prove it, we have to take 2 triangles here. Triangle ABC first, then triangle BCD. Which 2 triangles? Triangle ABC, right, and triangle BCD. So let us compare these 2 triangles. So between triangle ABC and triangle BCD, let us find out the possible conditions here. Here, as we know, in the triangle ABC, AB side is equal to, in the triangle BCD, BC side. Why? Because in the first statement we have proved that all the sides are equal. So it is by proved. Second condition is, as you can see, for the triangle ABC, BC is a side, and for the triangle BCD, this is also another side. So BC is the common side to both the triangle. Common side. Okay. Now third possible condition. For the triangle ABC, AC is a side, and for the triangle BCD, BD is a side. And we know in this quadrilateral, AC and BD are two diagonals. and already it is given that the two diagonals are of equal length. Okay, so we can easily write SC is equal to BD since it is given. So by S congruency we can write the triangle ABC is congruent to the triangle BC. So triangle ABC is now become congruent to the triangle BC. Understood? So now we will consider their corresponding parts. For the triangle ABC, B is a side. Yes, sorry, B is an angle. Similarly, for the triangle BCD, C is an angle. Okay, C is an angle. Since it is given the triangle ABC is congruent to the triangle BCD, so we can write that their corresponding angle must be equal. So they are equal now. Okay, this is our equation 1. We have find out this conclusion by congruenting two triangle ABC and BCD. Understood? Similarly, we will follow the same procedure and again compare another two triangles. BCD triangles, which triangle? Just look at my finger. BCD triangles and ACD triangles and make them congruent. Okay, we will make congruent to which triangle? BCD and ACD. Okay, BCD and ACD. Okay, so you can write similarly we can write what? That the triangle BCD is congruent to the triangle ACD. If you want, then you can prove it. Okay, ACD. But here there is no need to prove because you have to follow the same procedure also here in order to make them congruent. If these two triangles are congruent, this triangle and this triangle, then C is a what? C is an angle of the triangle BCD. And if you consider ACD, then D is an angle of the triangle ACD. But we know these two triangles are congruent. So we can write C angle is equal to D angle. Okay? Let's say this is equation number 2. Equation number 2. Again we will consider another two triangles. Which two triangles? Triangle ACD and triangle ABD. Okay, ACD this triangle and ABD triangle. Okay, we will follow the same procedure and we will find that these two triangles are also congruent. So you can write similarly triangle ACD is congruent to the triangle ABD. That means their corresponding parts, the corresponding angles must be equal. So for the triangle ACD, D is the corresponding angle, and for the triangle ABD, A is the corresponding angle. So we can write that their corresponding parts must be equal due to simplicity or axiom number 7.2. So let's say this is our equation number 3. Okay, now analyze equation 1, equation 2 and equation 3. From equation 1 and equation 2, equation 3, from equation 1, 2 and 3, we concluded that, what we concluded? We concluded that, see, B is equal to C here, B angle is equal to C angle. Okay, here we get C is equal to D, so we can write C is equal to D. Here we get D is equal to A, so we can write D is equal to A. So finally what we concluded? We concluded that each angle, angle A is equal to angle B is equal to angle C is equal to angle D. So all the four angles are of equal measure. Okay, by making the triangles to be congruent. We found that in this quadrilateral all the angles are of equal measure. Okay. But we have to find that they are of each 90 degree. How? Let us find. Since there is no space, so let us find here. Okay. See, it is a polygon and it has 4 sides, so it is a quadrilateral, right? So sum of all the 4 angles must be how much? All the sum of interior angle must be how much? 360 degree. So we can write that angle A plus angle B plus angle C plus angle D must be how much? 360 degree, because it is a quadrilateral. You can write here. Okay. Sum of interior angle. Sum of interior angles. Okay. Now We know all the four angles are equal. So you can write angle A. In the place of B, you can again substitute angle A. Here you can substitute angle A. Here also you can substitute angle A is equal to 360. So 4 of angle A is equal to 360 degree. Implies angle A is equal to 360 degree by 4 is equal to 90 degree. So what we find? We find the value of this angle A is 90 degree. We know all the four angles are equal. Then what will be the value of B? That is also 90 degree. What is the value of C? That is also 90 degree. And the value of D also 90 degree. So here we find that the value of each angle of this quadrilateral are equal and they are equal to 90 degree. Understood? So you can write A is equal to 90, B is equal to 90, C is equal to 90 and D is equal to 90. Clear? Okay, are you getting? So in the first statement we have proved that in this quadrilateral all the four sides are equal. Done. This is the first property of square. And the second property is that in this quadrilateral each angle is 90 degree. We have proved it. So for this quadrilateral we have proved or we have found or we have identified that all the four sides are equal, all the four angles are equal and they are 90 degree each. Hence ABCD is a what? It is a square. Okay. And finally you can write hence ABCD is a square. Okay, this is now understood.